Yeah, so my topic is a little special. It's this morning we talk a lot about what is AI memory and how do we build an application on top of AI memory. But my talk is more about how do we build a memory system and what is the infra. Okay. So I'm James, co-founder at Zillus. So we are a vector service company. So my talk will be like split into 4 sessions. First part is a little bit introduction about Milvus and Zillus. Then we talk about the challenge of how to build an AI memory system. Then we do have 2 different projects. One is Milvus database for serving, another one is Milvus Lake for helping you to batch processing all the contexts. Yeah. So first on Milvus, we are actually an open source project under Linux Foundation. We are like the most popular vector database on the GitHub, more than 40K stars, actually more than 100 million pods actually deployed in users' environment. Also, we have more than 300 contributors worldwide. So the company behind Milvus is actually Zillus. So we actually naming the company by zillion of zillion. This is zillion is actually a word we actually created, a palindrome. So our mission is just to helping organization to make sense of their unstructured data, for sure, including all the like AI memory data, like multimodality data, or the text, images, videos, audios. So our fully managed system, this called, is actually one of the best fully managed the vector DB service, and according to First Wave, is actually in the leader segments on their First Wave report. Okay, so just quickly show our logos. Many of the like NVIDIA, Apple, XAI, many of the AI companies and big companies are actually using us. So get if one day we're gonna have your company's name on this list. Okay. So back to the topic, right? What is the current challenge for AI memories? I think AI memory is just like teenage sex. Everybody talks about it. Everybody knows it's important. Nobody knows how to do it. Everyone thinks somebody else is actually doing that. So everyone claims that they also doing it, right? But that's a challenge. Okay. First of all, it's all important. I think this morning we talked a lot about how this is very important, but just to give you one example, if we're just trying to build an agent helping me to reply emails, and then I receive an email say, "Are you free tomorrow? Can we do a catch up quickly?" So the technical AI answer would be, "Sure. What's a meeting? What's the time available?" But actually tomorrow is my family day, so actually cannot attend, right? So we do need some kind of context information, help the agent better understanding what's going on there. And that is something we call as a memory. Okay. But how do you build AI memory systems? What is the challenge? Yeah, I think from day one, it seemed to be pretty simple and really nothing like different from just building a reg system. So the first step is how you do a high quality search across our data, right? The simple way is just to put everything into embeddings or graph and do retrieval. That is simple, but usually not as efficient, or usually has some major limitations. That's why we are actually in this room and have multiple ways to fix that. Yeah, so from our experience, only use embedding search might not be like the ultimate answer. So you also need to think about doing heavy search, filter search. Probably sometimes have to be a combination between graph and vector database. But yeah, as a prototype, I think it's not like hard, like super hard to fix that. Maybe just do it in 1 or 2 weeks, build a great demo, get a very good benchmark result. Then you step into challenge 2, right? How do you keep your performance on a large scale system when you deploy your agent into your production environment, serving like millions of your customers? Then that becomes a big challenge, right? As far as I know, most of the agent system or AI memory system we actually talk about this morning cannot serving like million level DAUs. So that becomes the second challenge, and we do need some scalable infra to handle that, right? And then your system keeps growing, you hit into other issues. Multi-tenancy is definitely one of them. You're definitely not building agent for yourself. You're actually building for many of your application users. And with the application becomes popular, that is a big headache, right? Usually what you do is just create one agent in one collection or one table. But the challenge is, look at your database, right? Is you really not be able to support million level tables, collections, right? So that become a pain. Okay, so if all the first three challenges has been solved, then congratulations, you have a very good memory systems, but still it's not perfect, right? So I think the further challenge is how you're going to convert those data into a more efficient format and get more like details from the raw data, right? All those chat histories, we need to do summarization, we need to do some deduplications, we need to find relations between knowledge base. The simple way to do that is just write a Python code and run it in the backend. But once you have huge amount of data that is not like really doable, then people do think using Spark, using Ray, or some kind of like distributed system to do that. And that becomes a big headache of how you can build a reliable offline pipeline for your feature engineering and preparing for your training data. Yeah, and then once you have it, last challenge will be this will cost you like tons of machines and also becomes really stable. I've seen a lot of big companies get into these pains, like they cannot, they have like data silos, a lot of people from different applications, but they want to serve them at like one data, one shot. Yeah. So how to process massive amount of data sets very efficiently becomes a challenge. And we definitely don't want to move data between different systems. Okay. So that's one ideal system. If I'm an application developer, that's something I want to build, right? So you have some raw data. It should be multi-modality structure plus unstructured data. First of all, you actually put those into your contextual memories, into your vector database, or it's your graph, whatever you do, some simple process, and it should be work at the very beginning. But soon it hits into some problem, then you start, maybe I want to fine tuning my model to solve those problems, or maybe I just want to get more deeper relationships. Probably at the very beginning, you just had one hop for data. But after a certain time, like we actually forgot something, then we need, on the other side, we need to like drill deep into all the like data insights. So that's why we need all those feature engineering and data post-processing our background and generate a lot of features. Then those features can be used either to like convert that into graph again or embedding again, or it can be just helping you to train those models. So then with like parametric, that's something we call parametric memory. Just think it as a Kiwi cache or just some like LoRa, but that could also help your agent to get better understanding of yourself or your customers. Yeah. So the challenge is all about inference, right? The ideas are simple. If you have 1 million data, definitely easy to do. But when you have like couple billion data, then everything becomes a really challenge. That's why we introduced two of our infras. One is Milvus database. So we call purpose-built database for AI mainly because of the data model. So we can easily convert any kind of PDF or any kind of like document, whether it's a web page, into a Milvus data model. We do have some special tricks on top of it. First of all, we actually combine dynamic schema and fixed schema. So if you want better performance, you do fixed schema. But sometimes your agent is like very flexible. Your data is dirty, so you definitely want dynamic schema at some time. Yeah. Also, we have multiple different vector queue support. So you can easily do a hybrid search between either deep dense embeddings, you can do sparse embeddings with BM25, you can do binary embedding search. We also support like multi-vector style support like Cobert, Copali, so you can like easily store all your embeddings or different kinds of your data into one system, and you can also like tag in your data and store it in our fixed field. We do support like strings, numeric numbers, and also like geolocation data, timestamp data. So that is good enough for like people to just build an agent. Yeah. And also like one of the fancy part for it is you can do multimodality data model. So some of them like data models actually fits video frame sequence, and some of them actually fit time series data. So you can always find a way to put your unstructured data into Milvus table. So second thing is like it's super scalable. So it actually helping you to solve the problem about how to scale. I know this is not a like infra meetup, so I won't go too deep into this. But the key idea here is like everything is like fully on the cloud. We actually leverage like infras like S3 and Kubernetes. So Milvus itself is stateless, make it super easy to scale. And the other side, we can also push down those code data onto code storage like S3 and still caching some of the hot data. That is super helpful under like multi-tenant use cases where some of your agent memories might be hot, but the others could be just stay in the corner and don't cost you too much on AWS. Okay. So multi-tenant is definitely one big challenge. I actually see it actually hits several times in the previous talk. So there are actually multiple different data models for that. The easiest one is just a one collection per tenant, but it's just that the limitation is how many collections or how many tables can create on your database. Usually it's a limited number. Most database I would say just less than 10K. Yeah, it probably not to fit if your application is just focus on like business customers. But if you're trying to build consumer customers, then definitely like 10K is not good enough. The other way to do that is using one collection for all your tenants, but then you soon hit into other issues like how do I do isolation? You can definitely do filters, but filters are actually kind of like slow, and also you get a lot of like access control issues. And how like then like a lot of issue falls into on how to keep that users data security and fast. So one innovation we does is actually support something in the middle. So when people interact with data, it's still one collection, but we actually split all the data into smaller partitions. So each part, think about each tenant can be one small part in the table, and it's actually physically isolated. So when you ingest and when you search, you still keep it as one collection, not too much meta information. But when you search on it, it actually only hits part of your data, and the tenant number can be like goes to up to tens of millions. So that is good enough for all the consumer applications, and it's extremely helpful when you're trying to build AI memories because you're actually building for multiple agents, and each agent can be just a one partition key inside the system. Okay. The other important thing definitely the cost, right? So we do have a special sauce which we call pair storage. So all the data is actually located in a pair storage way. So many data are just stored in object storage. All your code data cost as much as what S3 cost, right? But we do have several layer caching, so you can caching some of the data on your SSDs or even in memory. So hot data can be as fast as like tens of milliseconds latency, and the code that has maybe takes much longer based on like what kind of storage you're using. Usually 200, 300 milliseconds, but still good enough for many of the AI memory use case. Yeah. So that's Milvus database, mainly built for retrieving RAG for all the serving use case. Yeah, but as I just said, it's not enough. The key challenge is once the data accumulate, we always want to build something special, offline processing pipeline, helping us to keep finding insight in our data or in user status, right? That's some and many of our data maybe just stored in S3 or maybe just stored in something like Iceberg or maybe a data warehouse, a data lake. Yeah, so originally, we know a lot of people, they just migrate their data from Iceberg or Data Lake into Milvus, but that's definitely another challenge. And also you try to duplicate your data, it costs you double, maybe not double, but even more than that, because you do a lot of data governance and ETL. But right now, we actually support a feature which we call it internal table. So no matter what kind of format you're actually using, it can be Parquet, it can be Vertex, it can be Lens. We can just convert those data into our format and try to build another layer of index on top of it. So you can search on your code data without even copy it to a lot of different places. And what's more than that is we actually build an index on top of all the data, right? You have all the columnar data, but remember your embeddings. Sometimes you not only embeddings, but also you want to do some kind of regular expressions, and run each of the queries may take you minutes or even I think the query is the query I know is from Microsoft AI. So there's some kind of their internal queries take more than 20 days just to finding some training data set, right? So we're helping them to build index on top of it and shorten the time from 20 days to a couple of hours. So actually giving their data science a lot of benefits from not waiting, but also improve their GPU usage in-house, right? So with the index building, we call it one index because the index cannot be only used for Milvus itself, but it can also be used in systems like Spark and Ray. So you can either do serving with Milvus, but you can also do some batch processing. Say if you want to do deduplication of your data, or if you want to do some try to tagging your data, or even if you want to build a graph on your data, then the index can help you to accelerate Spark without need to migrate the data to anywhere else. Okay, so with the one data and the one index design, I think the final result we get is actually one semantic layer. So you have all your unstructured data, so you have your structured tables. Some of them is on your online system. I know a lot of people is using pgvector, PostgreSQL, MySQL, and then your after a while, after you might want to do a time to leave and move those data into your Iceberg. You might also have a Elastic for your search. And of course, you have a lot of offshore data. People upload PDFs, people upload images, a lot of crawlers working. Yeah, so you put all those data in one data lake. And inside the data lake, you have vectors, you have labels, you have your data summaries, some of them are blobs to store all those image and audio video data. And you put into one layer, and your agent can try to understand it. Especially, I think that makes total sense when models like Gemini 3.0 comes out, because what we see is no matter it's embedding models or it's large language models, it tends to be multi-modality and try to understand data from different source. Then you should definitely store all your data in one single source to make sure that your models can be easily able to, or your agent can be easily able to fetch all the data, right? Originally, we see a big data silo because data is actually located in different places, and it's maintained by different teams. So challenge is it's even not possible to get access to all your data. But right now you have one single semantic layer. You can do RBAC, you can do any kind of management on top of it. And you can also build index on top of it to do accelerations. So make your life much easier. Okay. So several use cases for our Milvus Lake. For sure, one of the most famous one is context engineering. So people do deduplications, summarizations, and they can also structure their context for AI agents and AI memory. Another interesting use case is multimodality search. We actually powering one of the world's largest autonomous driving company. So what they do is they actually collecting huge amount of data into their in-house data lake systems, and they want to, like, sometimes data scientists want to find a subset of their data to fine-tune their model. For example, if my autonomous driving car is driving and it's raining, there is a red light behind, like in front, and there is actually a dog past a road, and my car is not driving in the right way, then they try to find those kind of scenarios using like neural language and like select a bunch of images or videos just to do another round of fine-tuning. That's a use case. Originally, they do a lot of taggings, but taggings is actually limited because you have to pre-understanding what people are going to ask. But with embeddings, then you can cover a lot of different corner cases, and using index and lake, helping them to accelerate. Yeah. Third thing is data preparation. So we also working with one of the leading AI companies. So they have huge amount of data, pre-trained data. So they want to do very fast retrieval on the data, and they also do a lot of pre-processing using Ray. So we actually using this lake solution, combining it with Ray, so they can easily writing a lot of different UDFs to processing their data. Yeah, I think that's pretty much I want to share. So get to take questions, if any.